Here is the Algebra 2 review worksheet that you are assigned for homework tonight and all the answers and how to. For the first problem, evaluate the expression. You're going to plug -5 into this expression. So you have to watch the order at what you do. So I'm just plugging in 4 times -5. Everywhere I see an x, I'm plugging in a -5. So we have this right here has to be squared. -5 squared is 25, and 25 times -1 is -25. Now we're going to subtract what you get in here. 4 times -5 is -20. -20 plus 3 is -17. So what you have is -25 minus a -17, which is really -25 plus 17. So you have a negative and a positive, subtract the two numbers, you get 8, and it's going to be a negative because you have more negatives. So -8 is the answer. Number 2, you're going to simplify this by combining like terms. You have a negative in front of the parentheses, so you're going to distribute the negative. This is 11x minus 2y plus 5x. The like terms are the 11x and the 5x. You get 16x minus 2y. Make sure you alphabetize x comes before y. That's the preferred answer. Number 3, you have to use the distributive property. -3 times x squared, -3 times -y. So it's -3x squared plus, because it's a negative times a negative, 3y, and then do the distributive property again. So it's plus 6x squared, and then minus 8y. These two are like terms. You get 3x squared, and these two are like -5y. Number 4, you're solving equations now. So what you're going to do is look at this and say, we have variables on both sides. This is the smaller variable. So we're going to add the opposite, add 3x to both sides. So 2x and 3x is 5x, minus 5 is 8. And you're going to add 5 to both sides. 5x is 13, and then divide by 5. So your answer is 13 over 5. Number 5 is a little bit more involved. You're going to distribute the 2, so you get 2w minus 6 plus 4 equals 7 minus 5w plus 5. So you're going to add like terms. On the left side, 2w minus 2 is equal to -5w plus 12. Now the smaller variable is -5w, so if you add 5w to both sides, you get 7w minus 2 equals 12. Add 2 to both sides, so you get, and I'm going to write it up here, 7w equals 14, divide by 7, and w is 2. Number 6, how do you get v by itself? Here's v. So first what you'd want to do is bring this whole term to the other side. You get h plus, this is going to, if you add 5t squared equals vt, and now you're going to divide both sides by t. So what you can do is just do one bar and put a t underneath. So v is equal to h plus 5t squared all over t. Next. Number 7, how do you solve for x? I want to get x alone. So I want to bring -4y to the other side. So you should get 8 plus 4y. And then since I want to get x by itself, I'm going to divide both sides by w. So x is equal to 8 plus 4y all over w. Next. We have 4 consecutive even integers. 4 consecutive even integers. So if we don't know what the first one is called, n, The next integer would be n plus 2, and then n plus 4, and n plus 6. This is how you would write 4 consecutive even integers. We want their sums, so you'd add these expressions and sum them up. They set this equal to 220. Simplify this, you get 1n plus 2n plus 3n plus 4n. 4n, and then 4 and 6 is 10, and 2 is 12, equals 220. Subtract 12. So 220 minus 12 is 208. So 4n equals 208. And then what you're going to do is divide that by 4. You should get 52. So n is 52. So if the first number is 52, add 2. So you get 52, 54, 56, and 58. If you added these up, you would see that they add up to be 220. The next, it says the sides of a triangle are in the ratio of 2 to 3 to 6. So what we do is we write 2x, 3x, and 6x. You're going to add them up because the perimeter says it's 88. So what is 2x plus 3x plus 6x? So you get 11x equals, whoops, this is an 88. Divide by 11, and x is 8. So if x is 8, 2 times 8 is 16. What are the sides of this triangle? So what is 2 times 8? 16. What is 2 times 3? I'm sorry, 8 times 2 is 16. 8 times 3 is 24. And 6 times 8 is 48. These are the dimensions of the sides of each of this triangle. The next one, it says you have to be able to translate an inequality into a problem for you to solve, but they don't ask you to solve it. So it says 3 more than, you're going to switch them around. It says the product of a number and 6. So 3 is more than the product of a number and 6. We don't know what this is. We call that x. So I would write 6x plus 3. It's at most. If it's at the very most, it's less than or equal to 15. And the product of 6 and the sum of a number and 2. So we're multiplying the product of 6 and the sum of a number and 2. So x plus 2 is greater than 24. Next. How do you solve this inequality? Well, you're going to pretend like it's an equal to problem, but if at any points you have to divide by a negative, you flip the sign. So 2 minus 3x is greater than 56 minus 14x plus 12. On this side, 56 and 12 add up to be 68. And then minus 14x. Okay, the smaller variable is the negative 14x. So I'm going to add 14x, add 14x. So I get 2 plus 11x is greater than 68. I subtract 2. 11x is greater than 66, and divide by 11, and you get x, x is greater than 6. Next, now if you had to graph this, if it's asking you to graph it, you would have a parenthesis at 6 and shade to the right. Number 13, they want to know, is this always, sometimes, or never true? Well, let's simplify this. 6x minus 12 plus 2x equals 3 plus 8x minus 15. Well, on this side, I can add these two up. You get 8x. On this side, I get 8x minus 12. These cancel, and so do these. These are the same thing. So does 0, ask yourself, does 0 equal 0? It always does. For number 14, we're going to distribute this 5 on the right side. These 5x's cancel. Now ask yourself, is 3 less than 5? Yes, it always is less than 5. 3 is always less than 5. The next one. It says we have a rectangular yard. And the width is given to you as 15. And if it's rectangular, if that's 15, so is this. We don't know what the length is, so we call this x. But it says that the perimeter is 80. It's at least. If it's at least 80, it's more than that. It's more than that. So it's greater than or equal to 80. So perimeter means you add up all the sides. So x plus 15 plus 15. We want this to be greater than or equal to 80. So x and x is 2x, 15 and 15 is 30. We're going to subtract 30 from 80. You get 50, divide by 2, and you get 25. So in other words, this dimension has to be at least 25, if not larger. So here's the graph of all the possible units the length can be. Number 16, this one is an OR problem. You do these separately and then graph both of them on the same number line. So when I have a fraction, I like to get rid of this denominator. I'm going to multiply. Actually, you could actually just subtract 4 on this one. This is an easy one. Subtract 4, you get 1/3 x is less than -1. Then multiply this by 3 and this by 3. So x is less than -3. Don't forget to bring the word or down. And we have 2x plus 2 is greater than or equal to 5. Subtract 2. 2x is greater than or equal to 3. Divide by 2. X is greater than or equal to 3/2. So here is part of the answer. X is less than or equal to -3. Or x is greater than or equal to 3/2. The graph of this, your critical numbers are -3 and 3/2. You should have a parenthesis at the -3 critical value and a bracket with the 3/2. And you're shading opposite ends. So all of the numbers in the shaded region are a solution to both of these. The next one is an and. You're looking for the intersection, so you're going to subtract 5. 2x is greater than -2. Divide by 2, and you get x is greater than -1. Bring down and. -3x plus 3 is greater than 18. Subtract 3. -3x is greater than 18 minus 3 is 15. Divide by -3, and this is where you have to flip the sign. X is less than -5. So where are all of the x values greater than -1? Here's -1, this way. And where are all the numbers less than -5? Well, that's over here on this side. So that's going this way. So where, this is an and problem, it's the intersection. And it doesn't look like these two are intersecting because -5 is smaller than -1. So there is no solution. These two are not intersecting. Okay, there is no solution. There's no graph. Number 18. This is an OR. We're looking for both. Both of these go on one graph. So first, I would subtract x. 3 is greater than 2x minus 1. Add 1. 2x less than 4, divide by 2. 2 is greater than x, and I like to rewrite it like that. On this side, you have 4x plus 4, and then plus 3 is greater than or equal to negative 5. 4 and 3 is 7. Subtract 7, and divide by 4. So x is greater than or equal to negative 3. This is an or, so where are all the numbers? I'm going to write this down. This should be if x is greater than or equal to negative 3, or x is less than 2. Let's graph this and see what it looks like. Here's a 2, parenthesis, and you're going to shade this way, and negative 3, and you're going to shade that way. Looks like all real numbers is the answer. Looks like the entire graph is shaded. So where are all the numbers that are greater than or equal to negative 3 or less than 2? The answer is all real numbers. So sometimes you have to graph it to see that that's the answer. Number 19. This one has variables on both sides, so let's add an x. You get 3x minus 4 is less than 8. Add 4. 3x is less than 12. Divide by 3, x is less than 4. And 3 times 2 is 6, minus 3x is less than or equal to 9. We're going to subtract 6. Negative 3x is less than or equal to not 3. Divide, and you're going to flip the sign, and you get a negative 1. So where are all the numbers that are great? We're going to put these in order. This is smaller. And x is less than 4 would be a bracket at negative 1, a parenthesis at 4, and you would shade everything in between. Number 20, you are going to first get rid of this 2. Let's add 2. Negative 2, absolute value 4x plus 1 is equal to negative 14. Then divide both sides by negative 2. 4x plus 1 equals 7. Now, if this is a positive number, you can continue. How do you continue? You're going to break this up into two problems. 4x plus 1 equals 7. And 4x plus 1 equals negative 7. And do them both. Subtract 1. 4x equals 6. And divide by 4. 6 fourths or 3 over 2. That's one answer. Subtract 1. 4x equals negative 8. X equals negative 2. And negative 2 is the other answer. So 21, this is the one where we have a variable on the other side. So when you do this one, you've got 3x plus 4 equals x plus 2. And you've got to do 3x plus 4 equals negative x plus 2. This is one where you're going to have to check both answers to see that you might have an extraneous solution. So let's try. We subtract x, and we have 2x plus 4 equals 2. Subtract 4, you get 2x equals negative 2, and you get negative 1. Now I already know this is not going to work because when I plug, oh actually it might, let's see. Because this is smaller, or this is bigger than negative 1. So if I plug a negative 1 in here, 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. The absolute value of 1 is 1. And if I put a negative 1 here, negative 1 plus 2 is 1. So it does work. That one does work. So negative 1 is a good answer. Let's try this one. We get 3x plus 4 equals negative x minus 2. Add an x, you get 4x. Subtract 4, you get negative 6. And divide, you get negative 3 halves. Now this one I know is not going to work because when I plug this number, this is negative 1.5. Let's try it. We're going to have to check this one. So 3 times negative 3 halves plus 4. Does this equal negative 3 halves, which is negative 1½ plus 2? Do these two sides match up? Well, this is going to give you 3 times negative 3 halves is negative 9 halves plus 4. You're going to take the absolute value of that. So this is negative 4½ and the absolute value of that is going to be 0.5. And then this one is 0.5. So they both do work. So this answer does also work. Next one. This is a less than, it's an and. You're going to subtract 3. 3x minus 6 is less than 12. This is an and problem. So you're going to write 3x minus 6 is less than 12 and greater than negative 12. How do you solve this? We're going to add 6. So you get negative 6 is less than 3x is less than 18. Divide by 3. So you get negative 2 less than x and less than 6. So x is between negative 2 and 6. X is less than 6 and greater than negative 2. The graph of this looks like that. And we're going to shade in between. Next, 23. This is a less than, but we have a negative 3 out here. So we're going to divide both sides by negative 3, and we get absolute value of 6x minus 5 is less than or equal to negative 3. Now, when you take the absolute value, this is a special case, when you take the absolute value of any number, it's always going to come out to be positive. Is a positive number less than or equal to a negative? It's never. So this is an example of a no solution. You can never take the absolute value of a number and it be less than, when you take the absolute value of a negative number, it's going to come out positive. And it won't be, a positive number is never less than a negative. Now, if this were a greater than sign, it would be all real numbers. So if the sign was reversed, you can take the absolute value of a number, it's going to come out to be positive, and a positive number is always bigger than a negative. So if this sign would have been reversed, a greater than or equal to, that would be all real numbers. But this one is no solution. And for this one, you would divide both sides by negative 4. So you get absolute value 2x minus 5 is less than or equal to 7. And now this is an and problem. So you're going to break this up into 2x minus 5 is less than or equal to 7 and greater than or equal to negative 7. So add 5. So negative 2 is less than or equal to 2x, less than or equal to 12. Divide by 2. Negative 1 less than x, less than or equal to 6. These are both less than or equal to and 6. So x is between, x is less than or equal to 6 and greater than or equal to negative 1. It looks like this graph. And you're going to shade in between. Okay. Number 25. A friend is planning a trip to Alaska. He purchased a coat that is recommended for outdoor temperatures from, so the temperature can range from negative 15 all the way to 45 degrees. Okay, so I need to know what's the halfway number. So if you add these two numbers up, 45 plus negative 15, you get 30. And divide that, so 45 plus negative 15, you get 30. Take that number and divide it by 2. So 15 is your halfway number. You take the opposite of this number, so it's x minus 15, and this is an and problem, less than or equal to. How many units is 15 away from 45? And negative 15 away from 15 is 30. And that is the answer. We are done.